Hi, my name is Matthew, and in this video we're going to talk about systems of inequalities. And we're going to cover linear inequalities and nonlinear inequalities. We're also going to look at graphing more than one inequality at a time. Therefore, we'll be graphing a system of inequalities. And this is a build-up to the next video, the next section, which is about objective functions and constraints and building even more complex systems of inequalities with an end goal in mind. So there is a very distinct purpose for learning this material. We'll get to that in the next video. Let's have a look at just sort of the bare bones and the process of working with systems of inequalities. So we're going to be working with the greater than or less than or equal to symbols. We'll be working with two variables on the xy coordinate plane. Here's a step-by-step approach for graphing a linear inequality in two variables. You're welcome to read that. I'm just going to talk through the process using my own description. Here's an example of an inequality that we might be able or might be asked to graph. I'm not going to use this one because I'm going to show you how to graph a linear inequality by showing you how to graph a system of linear inequalities. So I'm going to hold off on that one for the moment, but we'll get to it, I promise. Yeah, this is true. You can graph inequalities without using, this says without using a test point. That's true. I'd like you to get in the habit of using a test point, and I'll show you what that entails, because sometimes the only way to get the correct solution is to use a test point. I really like the idea of starting with these. So a vertical line has an equation x equals some number. And if this is your inequality, x is greater than some number, then what we're going to do is shade the half of the plane that's to the right of x equals a. And let's see, here is an example. So where would we shade the graph of this inequality? In fact, let's just graph the solution to this inequality. The first step in this process is I just pretend that I'm working with an equal sign, x equals 2. And I'm going to draw just a little sketch of that graph. Now, the trick that I use to remember how to graph an equation like this is I'm graphing all of the points that have x values of 2. X equals 1, x equals 2. And so all of these points have x values of 2, so I must be working with a vertical line. Now, I drew a solid vertical line because this says less than or equal to. So if there's an or equal to, implies that we need to graph using a solid line. If it were a strict inequality and it just said x is less than 2, then this vertical, this vertical line that I just drew would be a dashed line. So you could put another little note in here that says maybe if, or right, if strictly less than, or if strictly greater than, then dashed line. And I'll make sure that we work an example where we have to do some of our graphing using a dashed line. Okay, step number 2 is I'm going to pick a test point. I'm going to use 0, 0. Now 0, 0 is to the left of the vertical line that we just drew. And I'm using 0, 0 as a sort of a representative as though you've got a representative of your county or your class or your state and so on. So I'm using 0, 0 as a representative of all of the points that are to the left of that vertical line. And I'm going to check and see if this point satisfies the original statement. X is less than or equal to 2. So I'm going to plug in, I only need my x value in this case because my original statement does not have a y value in it. It just says x is less than or equal to 2. So let's plug in the 0. Is 0 less than or equal to 2? Yes, it is. It's true. So step number 3 will be shade the region that includes the test point. Now, if we had tested a point that was on the right-hand side of the vertical line and it had tested true, it wouldn't happen in this case, then we would be shading to the right. But since 0, 0 is to the left of our vertical line, we're going to shade the left-hand side. So let me draw my graph one more time. That way we can see the original graph that had our vertical line on it before shading. And now that shading goes all the way left, all the way up, all the way down. And it comes right up to that solid vertical line. Any one of the points in that shaded region has an x value that satisfies this original statement. Let's look at a point. What about this point right here? What's the x value there? Maybe negative 1, 2, 3? An x value of negative 3. Is negative 3 less than 2? Sure is. So any point in that shaded region that goes, again, forever left, forever right, forever left, up, and down will satisfy that original statement. Okay, so that's a very basic graph. It's a vertical line. If we had been working with an inequality that had just a y value in it, like y is greater than b or y is less than b, then we would be graphing a horizontal line. If we're graphing the y values that are greater than b, we would shade the upper half of the plane. If it was y is less than b, where b is some number, then we would shade the lower half of the plane. So here we're going to graph a nonlinear inequality. So far, the only linear inequality that we've graphed was that previous one that was a vertical line. We'll graph one that looks like more of a diagonal in a moment. But this one says to graph this inequality. Now, the hope is that you know what this equation is going to look like. If you don't, I'm going to remind you. So the first thing I'm going to do is pretend that it's an equal sign. And remember that the less than or equal to symbol implies solid line. So this is an arrow. And we want to graph x squared plus y squared equals 4, and we're going to graph it with a solid line. That's the equation of a circle with a radius of 2. This is a squared plus b squared equals c squared. It's the Pythagorean theorem, essentially. And when we graph it, c squared being 4 means that c is equal to 2. So let's come up here. Let's have this be vertically 1, vertically 2, to the right 1, to the right 2, down 1, down 2, left. There we go. So let's graph this thing as best you can. All right, not bad for freehand. One of these days I'm going to get an app that would just snap that circle into place, but for the moment it's freehand, so that is step number 1. Step number 2 is let's pick a test point. Now I'd like to use 0, 0 again. I used 0, 0 in the previous example. Here I'm going to use it again. Do I always use 0, 0 as my test point? Not always. As a matter of fact, you can use any test point you want, as long as that test point's not on the line, or in this case, the circle, because I'm trying to determine which side of the circle or the line to shade. What's a good example? If there's a community and there's a house here, and there's a house here, and there's a fence between the two different people's yards, and one of these yards has brown dead grass, which is not good. The association is very upset about the brown grass that's in here, and one of the houses has really nice vibrant green grass. And I ask you, go determine which yard has green grass. And you walk over you drive over to these pieces of property, and you go over there and you look at the fence. You just go up, really just zoom right in on the fence. I don't think that if you look at the fence, you're going to be able to tell which one's green and which one's brown, right? You have to look to the right of the fence or to the left of the fence. So that's why you want to use a test point that is not on the fence. Use a test point that's to the left or to the right of the fence. Or in this case, use a test point that's inside the circle or outside the circle. So since 0, 0 is inside the circle and it's not on the circle, I'm going to use it. That makes 0 squared plus 0 squared. And I'm testing it in the original inequality, which is less than or equal to 4. And that is true. So shade the region that includes the test point. If it had tested false, then we would be shading the region that does not include the test point, which would be outside the circle. But since we chose a test point that was inside the circle and it tested true, we will shade inside the circle. So I'll leave it to you to write, so shade the region that includes the test point. Really, my scribbles look pretty similar to my regular handwriting anyway, so there's no need for me to write that out again. And really, that was step number 3. So shade the region that includes the test point. And we're shading inside again. It's the extent of my artistry. Brutal. In fact, it's kind of strange. The 2 pieces of artwork that you can see over my shoulder, this one and this one, that one my dad drew of himself and my mom when he was in when he was in college, and then this one he drew when he was in I don't know, he was probably in his 40s or something. They're unbelievable. Let's see if I can get him into focus a little bit. He was an incredible artist. He was an architect. Just a brilliant guy. I can barely draw a circle. I got a couple other skills though, so that's good. They're keeping me in business. All right, so in the previous problem, we shaded to the left of a vertical line. In this problem, we shaded inside of a circle. What's the answer? I haven't actually put any boxes around any final answers. I don't have anything that says like x equals the square root of 5. The answer is the graph. The answer is all of these points that are inside the circle, or all of those points that are to the left of my vertical line. So your graph for these problems, or your answer for these problems, will be a graph. Systems of inequalities in two variables. Interestingly, I suppose, if I took my previous answer, well, do I want to do that? No, let's not do that. That's confusing. All right, systems in two variables. So we've got a system of inequalities this time. There we go. Graph the solution set, right? It's a set of points, and we're going to represent it graphically as a shaded region. Or indicate that the system has no solution. What would it look like if a system of inequalities had no solution? I suppose I should address that. No solution. Graphically, if we shaded maybe a diagonal dashed line like this, and the shading was to the left of it, and then there was a parallel line, and the shading was to the right of it, if this is what this system looked like, because those shaded regions don't overlap each other at all, there would be no solution. Again, if we graph these two inequalities and we do the shading, and the shading does not overlap anywhere, then the system has no solution. There's no point that would satisfy both inequalities. So what we're hoping for is something more like maybe a dashed line here with some shading, and then maybe a separate line that comes through like this with shading here, and then you'll notice that there's some overlap in the shading, and that overlap happens down here. It's just that region that I've sort of scribbled on a second time, where those two shaded regions overlap. That would be our solution. We wouldn't include this shaded region in our solution. We wouldn't include this one in our solution. Those would be absolutely blank. Don't even leave them lightly shaded when you present your final answer. Just the doubly shaded region. All right, so let's try this system. 2x minus y is less than or equal to 4. How am I supposed to graph that? I would prefer to convert this into y equals mx plus b form. It's just so much easier for me to graph it like that. So let me do that. Maybe I'll even, I wish I could change the size of my eraser. I can change the size of my pens. I can change the color of my pens. I can change the opacity of my pens. Can't change the diameter of the eraser. Fail. 1, 2. Just like I label my equations in my system of equations, I'm going to label my inequalities in my system of inequalities. Let's work with number 1. We've got 2x minus y is less than or equal to 4. I'm going to rewrite it as an equation, just pretending that it's 2x minus y is equal to 4. Since it is less than or equal to, it's going to be solid. Inequality number 2, 3x plus 2y. Let's switch colors. Inequality number 2, 3x plus 2y is greater than negative 6. Write it as an equation. 3x plus 2y is equal to negative 6. And this is going to be a dashed line. It's a dashed line because this is called a strict inequality. Strict inequality. Therefore, dashed line. Write that down. That's going to help you distinguish between correct answers. Okay, so let's go back to inequality number 1. Let's prepare to graph this thing. So I'm going to solve it for y. So I'll subtract 2x from both sides. So I've got negative y equals negative 2x, and the positive 4 is still over there. And then I'll multiply both sides by negative 1. There we go. And then graph. And remember, it's a solid line that we're graphing. I've got a y-intercept of negative 4, negative 1, 2, 3, 4. There we go. So let's plot a point there. My slope is 2, so I'm going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. The more of these points I draw, the more accurate my graph's going to be. Now, if you're graphing online, all you have to do is click the appropriate points. And if your cursor is snapping to the grid, you don't have to spread these points out very far. Excuse me. However, that's not always the case. You think it's snapping, but maybe it's not. So it's a good idea to click on 2 points that are pretty far apart. These are pretty far apart. I'm just putting a straight edge on this thing over here. Did it draw my line? Of course it did not. It's because I'm touching the screen. There we go. And in fact, I'm using one of my dad's old rulers. It's a drafting ruler, so it's got scales. It's actually a 6-sided ruler. I like thinking of Dad while I'm working. All right, so this is line number 1. I'll label it with my 1. It's in blue, so that's helpful. And then let's test. Can I use 0, 0 as my test point again? Yes, it's not on the line. Very good. And I'm going to test it in the original inequality. So I have 2 times 0 minus a y value of 0 is maybe less than or equal to 4. 0 is less than or equal to 4. That's true. So shade. And we're shading the region that does include the test point. If you need to write that right here, then you write it. I don't need to write it. Maybe you do. Shade the region that does include the test point. Now, don't shade too dark. Maybe medium scribbles on this one. So I'm going to change my opacity here, and I might make my diameter a bit larger. And let's do some shading. Shading the region that included my test point because that test point tested true. All right, and then now let's go green. So we know that we're going to be graphing using a dashed line, but what does that line look like? Let's make this thing say y equals again. Subtracting 3x from both sides, I've got, 2y equals negative 3x, and the negative 6 is still over there. Divide both sides by 2. Y equals negative 3/2 x minus 3, because I had to divide the 6 by 2 also. And now we will graph. And remember, we're graphing a dashed line because it was a strict inequality. Y-intercept is at negative 3. So I'm going to punch in here a little bit. Y equals negative 3 is right there. And what was my slope? Negative 3/2. So I can rise 3 and run left 2. Or I could go down 3 and run to the right 2. In other words, this negative that's right here, hello, there it is. That negative right there can be associated with the 3, or it can be associated with the 2. As you plot some additional points to make sure that you're graphing your line correctly, clicking on a second point correctly. All right, let me continue doing this. Up 3 over 2, up 3 over 2, there we go, up 3 over 2. All right, let's draw our line there. And remember, it's a dashed line. If you're graphing these online, you have to make sure that you click on the appropriate type of line before you start your graphing, before you start clicking. Oh, I said dashed, and then I went and started drawing a solid line. There we are. Put some little arrows at the end of there. I'm going to label that as inequality number 2. And then let's decide where to shade. Can we test using 0, 0 again? Yes, because it's not on the line, it's not on the fence. We're looking in 1 yard or the other. Test 0, 0. So that is 3 times 0 plus 2 times 0 is strictly greater than -6. Is 0 greater than -6? It's not. Finally, that is false. So, shade region that does not include test point. And Sophie wants to come help us. Come here, baby. Come on in. Hurry up. Your sister will be knocking at the door any moment, scratching at the door. She's going to jump on me and scare me, probably. Since 0, 0 tested false, we're not going to shade the side of the green dashed line that includes 0, 0. So we want to shade the other side of the line. So we're shading below or to the left. So let me change my pen here. Drop the opacity, up the diameter. There we go. And there we go. Now, can you tell where the two shaded regions overlap? Yes. It's just this. Well, that's not helpful. It's just this left-hand portion over here. Oh, what happened there? Oh, there we go. It's just that left-hand portion there. If I were selecting my answer from a multiple choice lineup, if I had 4 multiple choice options, I would choose the one that has this solid line, that has this dashed line, and that only has the shading over here. Not lightly shaded up here, don't care about that region. Not lightly shaded down here, don't care about that. Both of those should be blank, blank, blank. So your final answer, again, only has that shading in this sort of left quadrant, so to speak. Why does the green keep disappearing? Where did it go? I don't know what's happening anymore. Let's put it back. One day I might look back on these notes. There we go. Nice. All right. So the solution to a system of inequalities is the overlapping shaded region, or the region where the two shaded regions overlap. The solution is the doubly shaded region. Figure out how you should phrase it so that it makes sense to you, and write it down somewhere. What else is going on in these notes? Do we have anything else? Nope, that's the next section. So we're going to talk about linear programming next. I hope this gives you a good start. You've got lines that you need to graph, circles potentially that you need to graph. There could be a parabola that you have to graph. And I should say that just in case you have to graph an inequality that's a parabola, pick a test point that's either inside or outside the parabola. This one you could still use 0, 0, and if it tests true, then you'll be shading out here. If it tests false, then you would want to be shading in here. All right, so use the test point. Don't just use the greater than or less than to direct you on where you should do your shading. All right, I've said shading enough times. See you later.